Okay, students, we're going to go through the solutions for the Chapter 7 test. Please make sure that you pay attention to all the things that you need to work on after reviewing the answers. Okay, so we have two similar figures here. We want to make sure that we are looking at the corresponding sides. So obviously these two are corresponding sides, these two are corresponding sides, and these two here are as well. We want to find the scale factor by looking at what values have been given for each of the shapes and for those particular corresponding sides. So because we have these two sides, I'm going to say my scale factor is 9 over 6 because that's 9 over 6. And this gives us an answer of 1.5. So that means that this object is 1.5 times larger than that. So if I was to go ahead and find the value for x, these two correspond to each other. That means these two will as well, and these two. So if I wanted to find the x value, I'm multiplying 3 by a factor of 1.5, and that will give me my x value there and this value is 4.5, which makes it 1.5 times larger than the original value there. If I want to find my y value, these two are corresponding, so this is 1.5 times smaller, so I take my 6 and instead I'm dividing this time. So x was multiplying larger and y is getting smaller. So this is an answer of 4. Okay, so a total here is 4 marks. Those two, and those there getting a total of 4 marks. Okay, so question 2 is similarity test. Which one proves that the given pairs of triangles are similar? If you have a look at both of these triangles, we see that there is a right angle in both. So it looks like there are two angles, and there's 40 degrees and 50 degrees here. So on first observation, it doesn't look like these two are similar, but if we use our triangle rule, we know that there's 180 degrees in a triangle, so this one's got to be 50, and this one here has to be 40. Adding them all up, we get 180. So these are actually similar. So we would go with angle, angle, angle. There's one mark there. All right, let's keep going. Question 3, for this pair of triangles, give a reason why the two are similar. So the question is actually stating that they are similar. So there's no doubt. So you actually have to decide from here. Now, you would see that there are parallel lines, which implies that these two angles are the same. So they're corresponding because of our parallel line rule, and also these two angles are the same. Okay, so there's already two angles that are the same, so AA is acceptable, and you would notice that this angle is shared. The small angle, it belongs to the small, and it also belongs to the large one. So AA or AA is also fine as well. Finding the value for x. So here's the small triangle. Here's the large triangle, 6 and 4, x and 8. All right, so obviously these two correspond, so we can get a scale factor, 8 over 4, which is equal to, this is 4 and 8, so that's actually 12. Okay, so this length is 4 and that whole length is 12, so this changes to 12 over 4, which is 3. And we can then go and find our x value, which is 6 times 3. So that's 18. So this is larger by a factor of 3. Okay, so one for that, one for that, for that, one for that. And this gives us the 3 and 2 for this one here. Gives us a total of 3. So running out of ink. Okay, all right, let's keep going. Prove, so remember when we're doing a proof, we need to give reasons. So here there's parallel lines, so we can also see that there are alternate angles that are the same. So these angles are the same, these angles are the same as well. And you can also notice that there's vertically opposite angles that are present here as well. All right, so I'd like you to follow along. Angle EDC, EDC, that's that angle there, is equal to angle ABC. And the reason is the alternate angle rule, and that is an angle. Okay, doing the same thing, angle DEC, angle DEC, so that's this angle in here, is equal to angle BAC, which is that angle in there, angle BAC. Same rule. There's an angle, and then now we're going to just go with DCE, which is this angle here, is the same as that one in there, angle BCA. This is vertically opposite angle, so then we say triangle DEC is similar to triangle BAC. And really, you can use one of these codes here because there's 3 points in all of them. Sorry, I just moved that across. So that's worth 3 marks there. For this, and for this, 2 for that, and for that there. Okay, so next question. Gareth wants to determine the width of the river shown in the diagram without crossing it. He places 4 markers as shown, 1, 2, 3, 4. Calculate the width of the river showing all steps. Okay, so let's have a look. We've got 2 triangles here. We are assuming that both triangles are similar. So we're assuming that this is a right angle, because this is. So I'm going to state here, assume both triangles are similar. Okay. Alright, so, and I'm going to also let x be the width of the river. So here is the width of the river. That's this side here. And that's what we need to find. So obviously, if we have 2 triangles and they're similar, because we've stated that here, we can find a scale factor. These are the corresponding sides. So it would be 30/10. So that means that this triangle is 3 times larger than this triangle. If we go ahead and find x, these 2 are corresponding. So we're finding the larger length, 7 times 3, which is 21 meters. That helps us to find out the width of the river. So calculate the width of the river showing all steps. So we say, therefore, the width of the river is 21 meters. Okay, so where do we go with that? Scale factor and answer. Okay, all right, so lastly, let's have a look at this question. I had a few queries about this one, so I'll break it down for you. All right, I've mentioned to you before in all these other examples that the scale factor increases, or sometimes if it's smaller than 1, it decreases the other shapes that we're talking about. So here, it says a square is enlarged by a factor of k. What is the area enlarged by? Okay, so a square is enlarged by a factor of k. So if a square is enlarged by a factor of k, let's say the side length of the original. Okay, so if we say the side length of square, side length of square, okay, so the original, let's call that L. If we are increasing this by a factor of k, that means the new square is k times L. Okay, so if we're looking at the area of the square, original and the image. So the original area is L squared because if it's a square, L times L is the area. So this is what we're talking about here. So if we're looking at the image, we're squaring both. So that's k squared, L squared. Okay, so if we consider this here, it says, what is the area enlarged by? Okay, so, sorry, not these ones. If we look at the area for the original is this, and the new area is this after changing this here. So it looks like the area has been enlarged by a factor of k squared. Okay, so this is L squared and it goes to k squared L squared, so therefore the area is enlarged by k squared, enlarged by a factor of k squared. Okay, so we're doing the same thing with the next question. It says a cube is being enlarged by a factor of 2x. So I can say the side length of cube, original and image, let's call that L again, and it's being enlarged by a factor of 2x. And then now we want to find the volume, so we're concerned with the volume. Okay, so the original is L and the volume is cubed. Because if we're looking, at a cube, right? Okay, if we're looking at a cube, right? The area of the cube is the area of the base. Let's say that's L. And all the sides are the same. So area of the base times the height. So area of the base is L squared, and the height is also L2, which is equal to L cubed. Okay, so there's that there. So how does this change considering that now? Well, we are cubing all of that, which gives us here, that's cubed, which is 2 to the power of 3, x to the power of 3, L to the power of 3, so this is 8. Okay, so how is this changing? Well, looking at these two now, we're going from L cubed. It says what is the volume enlarged by? So, and we're going to 8x cubed L cubed. So, therefore, the volume is enlarged by a factor of 8x cubed. So that's how that works there. All right. So the whole terminology about being enlarged by a factor of, have a look at this now. We say that x is being enlarged by a factor of 3 because it was 7 in the small, but it's being enlarged by a factor of 3. And that's exactly what we're doing down here as well. All right, so there's that, and there's that as well. So for a total of 17 marks.